Questions? Anyone? Please, here.
I'm Vicky Agrawal. My question is in relation to the solar wind mix we are going to have in India. Abhyankar, in your presentation, what you were showing under the different scenarios, 100 gigawatt, 200 and 400 gigawatt, when the solar was 100%, like you were taking wind 25%, solar 75, something like that. When the solar was 100%, then
you are asking question to Mr. Deshmukh, right?
Oh, sorry. Okay.
No, would you ask, please restrict question to Mr. Chaviwat.
Sorry, I am sorry. I thought we are asking the general questions.
No, we will immediately come to that. But is anybody has any questions? I have one question.
Yes.
Your results of differences in performance for AN and ABC is quite impressive. But frankly, I did not understand how ABC is contributing to it. Can you just explain it again? How does ABC work?
ABC, after the result of the ANN, after ANN train their data, then after that ABC come up to optimize their connection weight again. It means like ANN has a construction of the neuron for each layer, and between each layer there has the connection weight. And after
You've done an ANN.
Yes.
You've got the values of all the neurons and all the connections.
Yes.
And what does ABC do?
ABC change their connection weight and bias to achieve higher by the particle swarm, like by the change, what do we call? We call like numbers of particles and try to go to achieve the best result. What do we call? It's like in AI approach, something is we can solve the nonlinear for this approach.
Any other question for Mr. Chaviwat? Chaviwat.
It's the first row.
Susan Sun, University of Southampton. I just wondered how long the model takes to run, because I have no sense of...
Actually, not more than 5 minutes. It depends on my coding. Maybe my coding is not very good, so it takes about 4 to 5 minutes. I'm not very good at coding.
Okay, thank you very much. I think we can open it up for general discussion. Question to... including question to Mr. Deshmukh, to whom, please go ahead.
Yeah, sorry to Mr. Chaviwat again. Yeah. Okay, so what I was telling, Mr. Deshmukh, what you were showing, and under the different scenarios, when the solar was 100%, then the curtailment was maximum. In slide number 13, 14, something like that. And similarly, Koharan, in your recent study, 175 gigawatt integration, there also if we replace the 100 gigawatt solar and 60 gigawatt wind by 100 gigawatt wind and 60 gigawatt solar, then the curtailment is coming out to be much lower. So looking into these two continuous studies and all that, like what are the views? Is it the high time that technically looking into the things, whether we should think of some mid-term corrections in regard to the wind-solar mix in India? Another, I'll just add, because yesterday also we had seen so many presentations, almost in all countries in the world, except Italy, generally if we see wind and solar combination, wind is always higher than the solar. It was just incidental, but yeah, this is also one of the issues.
Another question, we'll take the questions first and then let's...
Yeah, I actually have a directly related question in the sense, to what extent are the results that we have for the optimal mix between wind and solar potentially biased by our modeling methodology? Of course, it's an advantage if the wind blows at night or it can provide energy at any point in time. But when we do the modeling, often we assume a perfect transmission network, at least partially. And basically, wind needs location-based flexibility, right? It benefits from locational aggregation at a larger scale and more strongly, while solar definitely needs the time-based flexibility, because once you reach the smooth shape fairly quickly, and then you need the time-based options. But in your modeling, you didn't have demand-side response in there. So in a sense, isn't it a bit unfair the way we model it, that wind often gets its flexibility for free in the modeling assumption, and solar gets its kind of natural flexibility often not in the model because it's a bit more difficult to integrate?
Let me add one more question to you, and that is this. You know, investment cost of a solar plant are much more than that of a coal-based plant, let's say. And if I want to replace 1 gigawatt of coal-based plant to generate the same amount of electricity, I will need to invest in 4 gigawatts of solar plant because of the lower load factor. So did you account for this additional cost of investment in your calculation of avoided cost?
So that's an easy one. Yes, I did. But I can talk a little bit more on that. But let me address the question of the mixes, and I think I'll address both questions simultaneously. I definitely agree that our modeling, the way we model these kind of scenarios, it definitely affects our results, and I definitely added that caveat that this is like a first step of looking at the mixes. I think going forward, including demand response and especially battery storage, which is not usually seasonal but diurnal, will benefit solar much more than wind. And I think including that would probably affect the swing of shares between wind and solar. So definitely agree that we should have included transmission as well, but there's a lot of uncertainty in the transmission costs. Modeling at shorter timescales might also affect some of the results. We model only hourly resolution. Even 15-minute resolution will probably give us similar results, but there are other factors that we could also look at as what is the cost of ancillary services for wind versus solar? Are they similar? The shorter time scale variability, is it going to be similar going forward? So I do agree that our models have limitations for that. That's why I hesitate to make a policy recommendation that we have to switch our targets from 60 gigawatts wind and 100 gigawatts of solar to switch it in the opposite direction. What I wanted to emphasize is we should keep an eye on how the costs evolve and also look at the value of wind and solar as we develop our targets. And we shouldn't just have like one fixed target just going forward. Like that was sort of the main message. And as to including the costs of coal, we did, all the scenarios were compared to no renewable energy scenarios. As I showed, the capacity credit in our analysis was really small, which means compared to a no RE scenario, we did invest in a lot of coal, like almost the same amount of coal as the no RE scenario. So we included those fixed costs in our total capacity credit. But even then, as the costs of wind and solar are coming down, we are still seeing substantial, like the additional cost is pretty small. Pretty high or pretty small? It's quite small in our analysis. But again, we have to include transmission, we have to include the ancillary services costs.
Jacqueline, you want to add something to all these things?
I'll ask Dr. Ranjit a question. Did you consider solar, like CSP and CSP with thermal at all for India, or is it worth considering?
It definitely depends on the cost of CSP. I think CSP costs may not be reducing as fast as chemical storage. I think the next step would be including demand response and battery chemical storage, especially to reduce the curtailment of solar in that diurnal variation. But CSP, we could definitely try including that, but we didn't include that in this analysis.
Yeah, hi, Kiran Arla from BSS Rajdhani. I wanted to know, would you model rooftop solar slightly differently, and would the results be different?
Okay. So I'll answer this question based on the analysis that we did with Dr. Cochran and Dr. Palchak, or David Palchak. So in the greening the grid analysis, what we assumed was 40 gigawatts of solar coming from rooftop PV. Now what we assumed was just areas, urban areas in our geospatial analysis, and looked at the solar resource just specifically in those geographical areas. But other than that, we didn't really do any different analysis compared to a utility scale solar park. Assuming that the solar radiation models captured the aerosol effects adequately, which means you will probably see lower radiation levels in our urban areas compared to solar parks, which are out in the rural areas with less aerosols. Those are the effects we hope to capture. But other than that, like perhaps increased operations or maintenance and all that stuff, like we didn't include.
Your assumption then implicitly is that the rooftop is all grid connected.
Yes, in the greening the grid, everything was grid connected, absolutely.
Any other question?
Just to add to that, we would, in our volume 2, we had a lot of transmission detail, and so rooftop PV would have benefited from not having some of those transmission constraints.
Any other question? Then I have a question to Paul. One of the question that you said, it was quite surprised that the amount of gigawatt which was not commissioned coal was very large in Andhra Pradesh and other things. Out of the 15 gigawatt of coal, almost 10 was not in use. Is there any reason for that, or it's just, why was it not available?
So actually, in that, all the coal is available for commitment and dispatch. It was just that in the least cost scenario, that coal was not the most cost-effective way to run the system, so it was left out of the commitment. So it's available to turn on if the system needed it. In Andhra Pradesh's case, there was a lot of wind and solar on, and it didn't need that coal to be on.
But then why was there cut? There was a red portion, the demand not met was there in all.
Actually, so curtailment, that is just curtailment of renewable energy. Should have clarified on that. That is just wind and solar being curtailed. Load is not actually curtailed in our model. We're meeting all the load. Yes.
Any other? Well, then, thank you all. Thank you, the speakers. Thank you, the participants. Thank you.